congratulations, Hassan. So right now, since we don't have, I have a formal presentation, but with one student, it doesn't, one participant, it probably doesn't make much sense to run the session through a formal presentation. So what I'm going to do first, then, since wait for other people, first see if you have any questions for us about our program, about any concerns or issues that you had thought about that you would like me to address for you. My name is Dr. Yasser Dasuki, and I'm the department chair of the Industrial Systems Engineering. I've been at San Jose State since 1997, so I pretty much understand not only obviously our curriculum and our department operations, but also to a larger extent, San Jose College of Engineering and San Jose State. I have Tom here joining me, who's an instructor for our state-of-the-art lab, V and Tim Lee lab. It's actually a lab that is a named lab due to a generous gift. And it's a wireless smart manufacturing lab. And Tom was actually one of our former alumni who's a guru in manufacturing and systems integration from that end. So with that being said, do you have any questions?
I'm interested in robotics, but not sure which major to pursue. So do you guys have any idea of like, can I get some guidance in which major?
Yeah, typically if you're in robotics purely, that's more of an ME thing, right? That's mechanical engineering. However, we do have in the college, ME has a minor in robotics. But with that being said, we have a state-of-the-art robotics lab. But we focus more not on the design of the robots, but how do we integrate a robot into their system for efficient manufacturing. So there's a difference. We want to look at robots and how they fit into a process, whereas mechanical is designing the robot to fit in the process. So it depends which end. So I guess with that being said, Tom, why don't you go ahead and start giving him the demo of our conveyor system, since he's interested in robotics.
Okay, sure, I'll be happy to. Let me share my screen and then I'll show you the robot, the lab. Okay, let me share my screen. Up. Okay, there we go. This is, let me get my camera. And hopefully you can see the lab.
Yeah,
okay, I want to move around, but the camera's gonna maybe be a little jumpy a little bit, but I apologize. But there's the lab, there's our lab. And we have quite a couple of robots here. This is the Hornet, the one you've seen right here. It's the Hornet robot. We have a Scare robot. This is a Scare robot. We have a couple of CNC machines that students usually use to build the parts that's needed for the lab. And then we have a SRS, a robot, a storage robot. And this is the conveyor system. Let me put my camera down. There we go. Oh, I've got mouse. And then we have 3D printers. We also have 3D printers. Yep, you can see that. Those are the 3D printers. Over there, a group of 3D printers. So let me go back here and do the conveyor systems. Let me show you. Everything is wirelessly. Here, I'm gonna go on to the system. Everything is programmed with drag and drop, so making it more easier for students to program it. So basically, you get the node, you drag it, you drop it, and that's how you program it. It's very easy. Once you're done with the program, all you have to do is deploy it, that you commit that change, and it's working. So right now, let's say if I want to tell the robot, go ahead and there's no pallet on the conveyor system. I want to initiate that and have it start picking up, building the parts for the system. So I will say, There we go. I'll just initiate it. I'll say, okay, run it. Let me go to my camera so you can see it. Oops. There we go. So I initiate that. It knows it. So I'm going to move the camera back out so you can see a bigger vision of it. So now it knows that it needs the parts for the conveyor system. The conveyor system is already getting ready to accept that. So now it's going to retrieve the pallet by the ASRS, automatic retrieval and storage system. So it's going to get that one pallet. There you go.
To the audience, as you can see, what we're really focusing on is not the design of the robot, is the use of the robot for systems integration and process improvement.
There it goes. Now it knows that it has the palette, and student usually use no red to program all this. It's very easy and quick because as you see, it's drag and drop. So a student can program the whole system within the 3 to 4 hours lab period. Of course, once they learn all the concepts. So integrate that. There we go. So now it sends it off. But when the robot senses that it's coming, it knows that, okay, I better start building parts. So the robot will react to that and start building the parts needed for that pallet. So we go get.
I should point out while you guys are watching this, all these devices are from different vendors. So there's a lot of difficulty in understanding how do you integrate components from different vendors. Sorry, Tom, I just wanted to point that out.
Mm-hmm.
What we're also working on in the audience is we have a CNC machine. And instead of already having the tops completed offline, what we're going to do is we have a CNC machine. So within the system, it's going to cut the part, the top, and then send it to the robot to cap it.
So while this is going, what courses from electrical and computer science are involved in your industry field?
We don't have any electrical engineering courses. We have a programming course, Comp E30 that the students need. Now, the kind of programming for this, you learn in the class because it's machine-based.
So let me move to the other locations. You can see the Hornet will start picking the peg and start put them in the pallet. So let me just leave my camera over here. Put that down. Okay.
Are you both admitted into ISE or into another major?
Right now, I'm admitted into mechanical engineering, but I'm just like going through every I'm going through the different programs and like trying to understand which one which each are doing.
Got it. How about you, August? August? And Nathan. I see two more guests. August and Nathan. What is your majors that you've been admitted to? Go ahead, Tom.
Okay, yep. So I'm just letting. I think there's more people just came, so then you see that the Hornet's gonna pick up the pegs.
Now, what we have to program, and it's going to happen here pretty shortly, is when they pick it up, they're going to put it in the pallet so it can be stored back in the ASRS system.
I'm gonna move because I'll move to the other side. down.
What type of math and physics courses would we need to, like, what level of knowledge would we need for this major?
What do you mean, this major, or for taking this class that uses this lab?
Oh, for this major.
Excuse me?
For this lab, and so like for this lab, for example, what kind of level of
You have to be a senior. Senior. You have to be a senior.
So then, like, what type of maths would we need to be taking for this major?
Well, first of all, for all engineers have the same math and the same physics and the same chemistry requirements, basically. So that's, you take that to your first 2 years. You don't take ISC courses until you're a junior.
There was some delay there.
Excuse me?
Oh, no.
I was saying thank you.
Did I answer your question, Hassan?
Yes, you did.
See, that's what Tom's now putting after they've completed the processing and the manufacturing, you're putting it back and storing it.
Okay, let me just show you now the 3D printers and the Csd machines that we also have in the lab that students use. There we go. What was my mouse? So we have a couple of 3D printers here. You can see we have the 4ANET 3D printer, and we also have the Rise 3D printer V2 Plus that it looks like it just finished printing some stuff, as you can see from there. But let me show you. So student usually in the lab is equipped with SolidWorks. So you will use SolidWorks to create the parts. So once you create the parts, let me go back here. So in SolidWorks feature. Okay, there we go. And so back in SolidWorks, so usually student, let me minimize that. So usually student use SolidWorks to build the parts. This is the top cap for the parts in the lab. So student can just simply, once they do that, they can just say, save that part to an STL file and then send it off to a slicer and then I'll print it off. So I'll just say, send that, I'll override that. So we send it in an STL file. Once we have an STL file, we can bring it up to any slicer. We can take it in any slicer, which is drag and drop it in here. So for example, I'll just delete that one we had. Let me minimize the screen. There we go. And then basically, then you can basically get that STL file that we have right there, drag it, drop it, and there we go. That's the part. And all you have to do is just, the next step is to use the slicer. We use Kira to slice it. So once you slice it, then you can send it off to a printer. All of our printers equipped it with a camera, and also you can send directly to it. You don't have to get up and send to the camera. So I want to say send that to a camera, send that to the 3D printer, and there you go. The 3D printer will start, and then right away from your seat you can see the action of the 3D printer. It's going to auto level. Once it auto level, and then it's going to start making the parts. Yeah, students love this because they can do everything from their desk in the lab, and then they can see it from the camera and everything. Now let me jump to same thing, SolidWorks. We use SolidWorks in the lab. Many students have SolidWorks experience because many of the class, they would be taking some class that has SolidWorks, that when they come in this lab, it's easy because we use SolidWorks also. So from here, I'm just taking further. So we can use this to build the parts. So for example, we're gonna, usually we get a stock material. This is the stock material to build the part, for example, aluminum or plastic. Once we have that, we can start saying, okay, because the part's much smaller than the material that we purchased. So we're gonna cut off the top part. Once we cut off the top part, then we go in and we start cutting the inside of that. And then students do that. And then we can say, okay, let's go generate code. Students can see, the effect of it first before they send it to the machine. So we'll generate the code, the truth path. There we go. We send the truth path. Once we do that, then we can go in SolidWorks. There is, no, this is being hiding it. Let me move it out of the way. Oh, let me move it. Okay, and SolidWorks has the SolidWorks CAM part. Then we can say, let's simulate that. Let's make sure it works. Here's our part, because the part is bigger than the stock material is bigger than the object we're going to build. So all we're going to do is say simulate that and let's see how it cuts through that. So we can see, okay, everything works, looking good. It's cutting through the stock to get to the object we want to build. Once it does that, you can see that, there we go. And it's going to cut into it. And of course, once it cuts into it, of course, it's going to fly off. So we, student put tabs on it so the object won't fly out of the holder. There you go. And there you go. Those are the tabs I was talking about. So it won't fly off. So those are the tabs. So when everything's good with the part, student will generate the code needed, which is the CNT G code. So they will say, post process, send that, build that G code. So I'll say, yeah, build the G code, numerical control. We'll say, yep, save that. We'll replace the old one. Then we'll say, go ahead and generate that code. That part takes about, 3,000 lines of code. So the SolidWorks will produce the required code for us. Once we have the code, we can then send it to the CNC machine. So let that process. It's about 3,000 lines of code of G codes. Any questions while this is generating the G code? Okay, once it's done, I'm just gonna close it, and then we can then send it to the CNC. So I'm gonna save it to a CNC machine. I'll just say 172.16.10.215, and then I'll say share folder.
So what is exactly G code again?
G code is the machine language that the CNC used to make the routes. So that's what G code is. And same thing as the 3D printer. Remember that 3D printer that we produce here is the 3D printer. It will produce the same thing as the G code. Let me just show you. Good question. Good question. So here is the numerical control that is sent to the CNC machine. That is the G code. So I want to open that with a notepad. In here, you see that is called G code. That is just basically saying go to X and Y axis, and then and then cut into the material. Go to X and Y axis, or Z axis, and cut into the material. In the case of a CNC, but in the case of a 3D printer, it will just deposit material on it. I'm just gonna take this out. I don't need a home mitt, for example. I'm not gonna use a tool changer. This is just a code. So that's perfect for our lab. We'll just save it. We'll send it off. In the case of the 3D printer, let me just go back into that. A while ago when we slice it, that's what it does. It basically cut it down to layers. So maybe this will help you understand it. So here is the cap again. So if I go into here and I can say, maybe you can see this, be easier to see. So I can break it down to layer. So that's what it does. So this is the first layer. It's going to deposit that. Let me go all the way down. There we go. There we go. And then I'm going to go up a layer, and then it's going to deposit each layer and each layer. And that is the G code. So if we run it, you have a better sense of it. So if we run it, let me take it all the way down again then. There we go. And I'll run it. There we go. So that's good. See, that's the first layer. That is the G code saying, okay, produce that circle. And that's the G code to do that. So let me zoom out. But there we go. So it'll go through all the steps. I'm going to push it faster. Then we go, that's the G code. So it goes to produce that. So if I were to say, instead of sending it directly to a printer, in the case of the 3D printers, I can say save your disk, for example, save to my disk so you can see the G code produced. So it's going to say G code, yeah, sure, onto my desktop. So I'll save it on my desktop. There we go. And I'm going to go to my desktop and so you can see that G code. Okay, there we go. And I want to look for my G code, right? Nope, that's not it. Where's my G code, right? That's my number control. And there we go. That's my G code right there. So that's the G code that we produced. We'll say, open it up. And that is the same thing. It's just saying, go to the X axis, go to the Y axis, and extrude this much of, for example, PLA, which is the material we use here. So deposit that much of plastic out, extrude 224. So, okay, so there we go. And talking about the CNC machine. So we send that out to the CNC machine. Let me show you. There we go. Let me just bring the mouse with me. Sorry about the camera movement. And we do have the CNC machine. And just in case, just an example of the 3D printer we deposit. This is, we just removing material. So this is our CNC machine. So I am going to start the machine up and I'll show you the camera also. Let me show you. So I will, start it. Okay, start, turn on the router. You probably can hear the machine running. And then that is the cap that we, built a while ago. So if I can move it around, you can see the cap in there. So that's what you go to, just basically telling it to go each layer and cut the material. So I am going to say, go ahead and run that job. So let me put the camera in there so you can see it. There we go. And then I'll just say, start the job. I'll say, run the job. There we go. And the CNC machine will go in and cut the material needed. There we go. It's time to cut. We can do, we got plastic, aluminum, wood, anything. Just some of the aluminum that we cut into, but there's some plastic we're coming to it now. Any questions?
Oh, Hassan, are you still there? CR.
Yeah, I'm still here.
So I don't want you to think that this is only what industrial engineering does. We're systems people. Our students are found in all industries. You've been to Disneyland?
Yeah.
You know the Fast Pass?
Yes.
We do. IE's designed that. So we are process people. So if you're interested in process design, then that's us. If you're interested in product design, that's mechanical engineering.
So if I want to do a minor in industrial engineering, am I able to do that?
Yeah, but the minor doesn't have this course. It's more on engineering management and quality, our minors, but not with manufacturing, not with systems manufacturing.
So what would I learn in engineering management? Like, what would the courses be teaching me?
What engineering management is exactly like the name specifies. How do you make the projects, make sure that they're costed right? How do you lead a team? How do you manage a project to make sure all the tasks and times, the tasks and resources and the people are available for the various tasks that you need to work on to complete it successfully? How do you teach ethics?
Okay. I think that's my. I don't think I have any more questions. So thank you for the time and information.
Well, good luck. And mechanical engineering has a very good program here and a very good reputation, just like we do in industrial engineering.
Thank you. See you later.
See you. Thanks, Tom. You're on mute.
Oh, okay. Yeah, happy to do demo.
It's amazing. It's amazing. The one person that stuck around for the demo was a mechanical engineering student.
It looked like he just went.
I found that ironic.
Yeah.
We'll stick around for 5 more minutes. And if nobody else shows up, then that's, thank you for your time then.
Yeah, no problem.
So what's your plans later? Are you gonna go work some more? Or
I have to go do my taxes. That's the plan.
That's a good plan.
I wait till the last minute because I know I have to pay back a lot towards this money. So I wait till the last minute for that. I'll use it up just in case if I don't, make it. At least I use it.
Yeah. I have a different. I always have to pay. Trust me, pay a lot. But I usually pay it when I'm soon because that way I don't spend it.
I'm the opposite. I'm waiting till the last minute. At least I can spend it before if something happens.
Yeah, it makes sense. You're probably better at that. That probably makes more sense, Tom. Your Uncle Sam keeps on taking more and more of my money, and I get less and less from him.
Yeah. So I got to do that today, and then after that, I finally got some free time.
Great. I'm glad you did.
Yeah.
You said that you live in Silver or Evergreen, right?
Evergreen, yes. I live in Morgan Hill, but my kid had some friends here and they cried and wanted to go over here. So we have to sold the house and now we're renting in just to have them go to the school that they want. So we sold the house in Morgan Hill. And so I'm right now renting because I don't want to be in this area. I like it in the country area. So
I see. Yeah.
So right now I'm renting to get them in, after high school and, middle school. The 2 girls should be done. One is in 11th grade. The other one's in 9th grade. Once they're done, then I'm moving off again. Yeah.
I know that you grew up in Modesto area. Out in the country.
Oh, you remember? Wow.
Oh, I remember. I definitely remember that story.
Wow, that's incredible. Yeah, I live further down than Modesto. It's Modesto, Turlock, and then Livingston. You blink, you miss it. There's only one stop into that town, and that town has population maybe 1,000. I lived and grew up there.
Yeah, and I remember the story you told me about your parents, that they didn't speak English, and and you had a lot of siblings.
Yep, we did.
I remember the whole thing. It was great.
Yeah, we came here with just the clothes on the back because running from war. And I know how the people from Ukraine must feel because, my family just ran and took off and whatever they have on their back, the shirts and pants, that's it. And came here to a foreign country, which they don't speak English. They don't. Right. Yeah, and then, so that's, we started from scratch. Anyway.
I trust me, every time I hear stories like that from you guys, it inspires me. It always makes me say that I have no right to ever whine about anything. Yeah, I think more people need to hear stories like you share.
Yeah.
And because today in America, everybody cries about any little thing, It's like they have, it tells me they just have too much time, right? To worry about these things, which are so, it's not really the big picture in life. And we argue about things that really is not going to matter in the big things. And that's why I always like hearing stories like yours, because it keeps everything in perspective.
Yeah.
Yeah, I think Ukrainians are a little bit more fortunate than I think the Vietnamese, is because Ukrainians can easily go to Europe, right next door, right? Whereas the Vietnamese, they had nowhere to go and they had to go from the boat, all the way to, the story is just, you hear, are just amazing.
Yeah, they take a chance. My parents jumped on the boat. They said they had no idea where we're going. There's no navigation, no nothing. Just go out there and drift, and hopefully we hit something.
Yeah.
And we were fortunate. We were very fortunate. We hit an American Navy ship, and they took us in. Yeah.
Wow, that's what a story.
Yeah, but
how old were you? How old were you, Tom?
I was 5 at the time. I was 5.
I bet you still have some memories of some, because I know I have memories, distinct memories of 5 years, just a couple memories, pictures of some images that just don't go away.
Yes, mind. I do. I sometimes they conjure up and I do see them. I do see the image in the camp. They put us in camp for a year or so. We're in camp. It's just muddy and just, you guys just live in a camp until someone sponsors to the U.S. And finally, we got sponsored into the U.S. and they took my family in so that we can help them work on the farm. So, my parents can, work on the farm. So that's what they did for a while. Yeah.
And you guys went straight to Livermore? I mean, what is it?
Livingston. Yeah, we went straight to Livingston. They sponsored us from, we were in Guam for a year. And then in the Kent for a year, living in Kent. And then after that, they sponsored us and we moved to Livingston, and that's where I was raised. And because my parents can't move anywhere because they don't know English, they don't have the So we lived there until I graduated from high school there, and then that's when we moved up here so I can continue to go on to school.
Livingston hasn't had its own high school, or you had to go somewhere else?
No, we're lucky. We were fortunate. We had high school. The surrounding has a smaller city. They had to come into our high school. So we did that at high school. Yeah. Was
there any other Vietnamese in the community, or you guys were one of the few Vietnamese in the?
We were the only one for a very long time.
Wow.
And then later on, then there were 2 families that came. So our family and 2 other families, that's it.
Wow.
And it was tough because zero English. My parents, it's hard to get around. We don't know the money system.
Right.
We don't know how to say, anything just to get something. So it was nice though at the time in 75, it was very nice. A lot of people know that we don't know, and they would drop off stuff at our front door so we can help us through. So that was nice.
That's I'm willing to bet all your siblings are doing well now. Just because
are they all doing?
I can just tell from your work ethic and what you learn that
they all did well. My sister, they work in pharmaceutical. They also graduated from San Jose.
My brother, love it.
Yeah, my brother is in. He actually, one not doing well. He's an artist, starving artist. But he graduated the top of his class in San Francisco Academy of Art.
Wow.
But art, he was great, but just that, it didn't fall in place for him. So, yeah.
Great. So do you get to, at your stage now, do you get to see your siblings a lot or no, because of your busy schedule? As you get older, you get to see them less and less.
We used to see each other a lot every weekend, but after my parent passed away, everyone started drifting away, and we don't see each other anymore. Everyone's moved on. After my parent, my mother passed away a couple of years ago. Then after that, well, I say a couple, but that's 10 years ago. And then after that, they all drift apart.
I've always heard that's the story. Once the parents, my mom, I have a twin brother, so I'll always be very close. And what I found out that would keep the family closer after the parents passed, my dad's still around, he's 95. And so we still keep in touch and we still email and I still see him when I go down there. But I think what helps is my kids were a lot of friends with their cousins. So if the cousins are closer, then it maintains that excuse to get together more than you would otherwise.
Yeah. Because everyone's so busy.
I know that.
They try
gotta have a reason besides just I know that. It's just very hard.
When mother was around, they all have to come. Everyone has to come every weekend. But
we would do that with my mom. My mom died of dementia, so she was down and we had to go visit her. just to, see how she was doing. And everybody took their turn, to go and do it. But Tom, it's almost 12:40 and we passed the 5 minutes.
Yep.
So I'm just going to make an executive decision and say, that's it. The session ends.
All right.
You have a nice wonderful time, Tom. Thanks again.
Have a nice weekend. Bye.
Service. Bye-bye.